So thank you very much. I'm very happy to be here and to discuss with you AI systems and how our human decisions impact what these systems look like. Before we get to artificial intelligence, human intelligence, how do I move forward with my slides? Okay, so there was a tool. It was not supposed to read my mind. Okay. Okay. Great. Thank you very much. Okay. So just so you know who I am and why I'm here talking to you about this, I'm a mathematician. I'm the CTO of Livant AI. Our mission is to make trustworthy AI a reality by making it simple for companies and organizations to develop and deploy systems that are trustworthy. So, okay, where do AI systems come from? Now, most of the time when we think about AI systems, we think of some kind of thing. A lot of times I feel like people think it's magic or it just appeared. But fundamentally, AI systems are tools that we created. And so let's not forget, there's a hardware part. Somebody actually built the computer. If it's built into a robot, somebody built the robot. And if we have some kind of IoT device, people built those as well. And then there's the software part. And the software part, again, there was somebody programming this. So by the way, I used Stable Diffusion to generate this picture. And so when I asked it to generate this picture, I said a girl talking to her mother. And it drew me a picture with a girl and her mother surrounded by flowers and plants and dolls. And I'm like, no, that's not what I wanted. So I said a girl talking to her mother in a room full of model trains, toy cars, and books. And somehow model trains and girls don't go. But I did manage to get it to draw a few toy cars. And the other thing, a girl is automatically white. And in order to get Stable Diffusion to draw something which was not white, I had to tell it, draw me a black girl talking to her mother in a room surrounded by books and cars and trains. And then I looked at that prompt and it just felt wrong. I don't want to have to call somebody a black girl, or what do I know, a Chinese girl, or I don't know, yellow, blue. So I went back to this one, but just so you know, already, when we type in a prompt, there is a default. That default may fit to us, but that default may not. Okay, and why do I want us to think about where AI systems come from? The reason is the impacts that AI systems have is not inevitable. It's actually based on decisions that we make. And we make these decisions all along the cycle of AI system development. So I want to start way, way, way back. So what kinds of research, what kinds of technologies are we putting our money and effort and resources on? And I would just like to take a look at this and have us ask the question, is bigger really better? So some of you should be thinking, wait, there's something wrong with this question. Anybody want to throw something out? What is wrong with this question? Yeah, bigger is better. Is there something wrong with my question? What's the definition of better? So who says what good is? And therefore, what is better? So you might say good is that the system produces output that sounds like a human being. Sounds like a human being. But you might say better is a system that produces reasonable output but does not have this kind of environmental impact. Or you can say, well, what problem am I trying to solve? And maybe I can do this with a smaller system. Why would smaller be better? Well, here's a thought. Big means more resources. It doesn't just mean more environmental impact. It means it costs more, it's more difficult to make, and therefore certain people and certain groups are automatically excluded from making the system. So I listed here 2 examples of attempts to say, whoa, hold on, maybe we can accomplish something good with a smaller system. Try to use a different kind of technology. Okay, next question. What is better? And here, having a system that produces plausible sounding output maybe is not what we want. So in this case, ChatGPT produced 6 precedence cases for the lawyer. They sounded plausible, but in fact, they were not real. And so the question is again, well, what is better? Is that what I want? That it sounds like a human being? Or is it more important to me that what comes out is true? And then we have the more classical garbage in, garbage out, which is what kind of data did I throw into my AI system? What patterns, what examples was the AI system learning from? And the first one is a very classical one. If you're training a system to look at job applicants and you train it on historical data, well, guess what? It's going to pick up historical biases. So if you're trying to look at applicants for technical jobs, maybe it will automatically exclude women, or it will automatically exclude people of particular backgrounds. The second one, now that we're all in the generative AI craze and almost everybody is using these systems to generate text, to generate pictures, well, consider this. If we flood the internet with AI-created content, our next generation of models will be trained on AI-generated content. Well, aside from the fact that there are theoretical reasons for thinking that's not going to end well, there is now research to say you're going to reduce the quality of your systems by doing that. Okay, here's another question. Again, AI systems are made by people, and there is content that's going into the AI systems that is made by people who are ignored or underpaid. So one, of course, we want chatbots that are not toxic. So I don't know how many of you still remember the chatbot Tay that Microsoft first put out in 2016 that very quickly became toxic and racist and sexist. So now, some people have learned, some people haven't. We still make that same mistake. But some people have learned and they say, okay, we want our chatbots and we want to try to avoid this kind of say offensive, violent speech coming out of our chatbot. But that doesn't just happen automatically. You have to have people who go through, label examples so that the AI system can, again, learn by example what is unwanted content. And the other issue also has come up, as these generative AI systems are based on content that we humans produced. Well, what about our rights to this content? Whether it's literary works or artistic works, these people have not been compensated for their work. Okay, now I'm going to get a little bit mathematical. Because AI systems are also based on mathematics. And when you build a system, you have to, for example, tell the system what to optimize for. What is the goal? So you have to take the concept of what is good and turn it into a function. And here we have actually a very telling example of a system that was deployed in the US. It was a triage system. Basically, patient comes in and the system has to decide, is this somebody whose condition is so severe they need to be treated as a stationary patient, or it's okay, they can be sent home and treated as an outpatient. Okay, but now this concept of severe medical condition. Well, they didn't want to pay doctors to sit down and label all of these cases to say, is this a severe condition or not? So they used a proxy. And that proxy was how much money was spent in order to cure this patient. All right, now think US medical system. Is there a chance that money spent is not equal across demographic groups? Yes. And in fact, after a few years, actually, that this system had been in place, they went in and they studied and they discovered, oops, it discriminates. It discriminates against African Americans. Okay. Now, obviously, this has to do with the data, but it also has to do with how they chose to optimize the system. Okay, next question. How do you evaluate the system performance? So let's say I have a computer vision system and I'm using it to detect lesions. Which metric should I use to decide if it has detected well or not? And here the problem is, in order to pick the correct metric, you don't necessarily need to be a mathematician or a machine learning engineer, what you really need to know, what you really need to understand is the medicine. And, well, what's worse? Is it worse if I miss a part of an existing lesion, but I get all of them? So if you look at prediction 2, it actually detected all 3 lesions, but it didn't get the correct shape of one of them. Or is it worse if I miss some of the lesions, but I get the full area of one of them? And, well, deciding what's worse and what's better is really a medical decision. Like, those other 2, they're small, so maybe it really doesn't matter if I missed them. Or, no, it's really important to catch all of them, and then we'll go in and look and make sure we get the right area. But making that decision will have a fundamental impact on what kind of diagnostic tool you've developed. Now, there's actually a very a different example about how do you evaluate the performance, which had a very different impact. And this comes from natural language processing, where it turns out what people thought was a huge advance in natural language processing, in particular in NER, named entity recognition, well, it was actually not due to representation learning, word embeddings, and all this other cool language model stuff that we're doing now, as they thought. It was due to the fact that at the same time they switched metric. And with the switch of metric, all of a sudden, representation learning looked great. And since then, all the funding has gone in that one direction. So choosing the right metric also means choosing which direction our future research and future funding will go in. Okay, other human decision that goes with AI systems. So let's say you have one. It's in use. You've deployed it. It's come up with a decision. What do you do with that? Do you just blindly follow it? And unfortunately, this is only the first of many examples where facial recognition has gone terribly wrong. And I have to say, I'm a little amazed at this. So they did it once. It got on the headlines. It was a big scandal. And did they stop? Has anybody been following this? No, there have been other cases. Okay? But it's still up to us. It was still a human decision to keep using the system and to keep following blindly the output that comes from the system. So I just wanted to bring this to a close here and say, let's remember, algorithms are made by humans. And, we make a lot of really cool things, but everything we make contains errors. So let's take them like this. We know we're making something. We know we're going to make errors. How can we develop these things with open eyes so that we understand when we're liable to make a mistake, what the impact of our mistakes are going to be, and try to take into our own hands the control to make it better. So that was my little call to action, because you know what? We can do better. And there are systems that we can produce that will actually bring us further and help us to solve problems instead of only creating ones. And I brought only 2 examples, mainly because, well, I think they're really cool examples. Also because before I say that something is good, I want to have tested it and made sure for myself that it works. And that's kind of hard to do. So what do I like about this example? Here, people used an AI system to help them overcome a human bias. So what this system does is it can detect sources of pain that are often overlooked by radiologists and for minority groups, okay? People who would normally go to the doctor say, I'm having this pain, and the doctor would tell them, it's in your head, I can't see anything, okay? So I think this is a great way to use AI systems. Okay, I started the talk by pointing out how much energy especially these very large AI systems consume. But at the same time, we could use AI systems to help us reduce our energy consumption and reduce our environmental impact. And so this is an example of using AI to reduce the CO2 footprint in manufacturing. And I would really wish that we could use AI systems in these ways in order to actually solve real problems without creating new ones along the way. So thank you very much for listening. And I would be very happy if you have questions.